Evonik Industries is one of the world's leading specialty chemicals companies, with a presence in more than 100 countries and a clear focus on major global megatrends. Products ranked among the market leaders account for the vast majority of its sales.
It is 1908, the dawn of a new century, at the cusp of the modern industrial age. In a small chemical factory at the foot of the Austrian Alps, Evonik has just become the world's first company to commercially manufacture hydrogen peroxide. Today, with production sites for hydrogen peroxide around the globe, Evonik is one of the world's leading suppliers of this key industrial chemical. Nowadays, hydrogen peroxide is produced using a continuous auto-oxidation process, also called AO process. Although there have been many technical refinements and innovations in the use and handling of hydrogen peroxide over the years, one thing has never changed: our commitment to safety. That is why we are proud to present to you our latest safety video. This presentation was developed to familiarize you with the unique chemical and physical properties of hydrogen peroxide and to provide specific instructions for ensuring that hydrogen peroxide is handled and stored in a safe and secure manner. Let's begin with a brief description of the chemical properties of hydrogen peroxide. A hydrogen peroxide molecule consists of 2 atoms of hydrogen and 2 atoms of oxygen. Its chemical structure can also be represented with the formula H2O2. Special substances are added to commercially available hydrogen peroxide to ensure the product remains stable. By this we mean prevent its decomposition under prescribed storage and handling conditions into its constituent parts. When hydrogen peroxide decomposes, gaseous oxygen is released, and what remains is water, H2O. Hydrogen peroxide is one of the purest and most versatile chemicals available. The preference for oxygen-based combinations has made hydrogen peroxide the widely accepted choice as a bleaching agent, chemical oxidant, and disinfectant. Today, about 50% of total worldwide hydrogen peroxide production is used as an environmentally responsible bleaching agent in the paper and textile industries. Other important industrial application areas for hydrogen peroxide include environmental systems for wastewater and exhaust air treatment, chemical synthesis for the production of basic chemicals and fine chemicals like pharmaceuticals, consumer goods formulations like detergents, antiseptics, and personal care products, food processing, in particular food packaging, etching electronic printed circuit boards. This requires an ultra-pure form of H2O2. In the mining industry, for extracting metals and for detoxifying effluents containing cyanide from gold extraction, and a host of other applications. Hydrogen peroxide for industrial use is sold as a watery solution in concentrations of 35, 50, or 70%. As you can see from these beakers, all hydrogen peroxide concentrations in small quantities are clear and colorless, very much like clean water. In larger quantities, as in a large drum for instance, or a tank rail car, you can make out a slightly greenish coloration. To be safe, any clear liquid you see near a peroxide storage area should be considered to be hydrogen peroxide until proven otherwise. The same oxidizing properties that make hydrogen peroxide such an invaluable industrial chemical also mean that any containers and facilities used for transportation and storage display special labeling. Hydrogen peroxide is classified as a chemical oxidizing agent and must therefore be identified with the oxidizer warning label. In addition, hydrogen peroxide is also classified as a corrosive agent, and must be labeled accordingly. Any regulatory labeling standards and ordinances must be strictly adhered to. The chemical decomposition to water and oxygen results from an exothermic reaction. In other words, in a process that generates heat. The decomposition reaction of hydrogen peroxide can be represented with a chemical equation. The decomposition reaction can generate a considerable quantity of heat. For instance, a 70% hydrogen peroxide solution that is decomposing can generate temperatures which in extreme cases can far exceed the boiling point of water. Under normal storage conditions, commercially available hydrogen peroxide solutions remain very stable. They lose less than 1% of their original concentration after 1 year of storage. Here, any heat generated in the solution is completely dissipated by the liquid and the container, and the hydrogen peroxide retains the ambient temperature. In the case of rapid decomposition, however, the rate at which heat is generated can be higher than the dissipation rate. This leads to a self-accelerating reaction. Any increases in temperature, the presence of impurities in the solution, or the pH, can have the effect of accelerating the decomposition of hydrogen peroxide. The impact of such changes can range from a reduction of the product concentration all the way to an uncontrolled reaction that generates strong heat and high pressure. It is therefore absolutely necessary to handle and store hydrogen peroxide in such a way as to minimize the risk of decomposition. Let's now look at a number of ways for ensuring this. Storage temperature is an especially important variable. A temperature increase of just 10 degrees Celsius will actually double the decomposition rate of the hydrogen peroxide solution. To minimize the risk of product decomposition, the storage temperature of hydrogen peroxide should be kept on average under 30 degrees Celsius and never exceed 35 degrees Celsius. In locations where the climate is conducive to such high temperatures, storage facilities and tanks must feature external cooling systems. Impurities in hydrogen peroxide solutions can also accelerate the decomposition process. Many commonly used chemicals, such as sodium hydroxide, but also transition metals, for example iron, manganese and copper, and organic compounds, for example wood or leather, promote the decomposition reaction catalytically. Even the most minute concentrations of impurities, less than 0.1 milligrams per kilogram, can increase the decomposition rate. A higher decomposition rate is usually triggered when a non-compatible chemical is erroneously introduced into a container with hydrogen peroxide, or when process fluids re-enter the storage container due to a faulty line design or a system malfunction. The flask we see here contains a rusty iron bolt. If you pour in a 50% solution of hydrogen peroxide and then seal the open flask with a balloon, you can see how quickly the peroxide solution decomposes. It releases enough oxygen to fill up the balloon. The decomposition reaction also generates a substantial amount of heat, which cannot completely dissipate in the liquid phase. This leads to a self-accelerating reaction. If the container is not adequately ventilated, the excess pressure can cause serious damage, as we can see here with our balloon. Theoretically, the complete decomposition of 1 liter of a 50% hydrogen peroxide solution can release 1,300 liters of gas. In a confined space, the increase in gas volume raises the pressure and can create a serious safety hazard. It may even rupture lines or containers if sufficient precautions are not taken. If peroxide manages to escape, you also have an increased risk of fire and injury. Other chemicals handled openly at the plant can also be a potential source of impurities. Many hydrogen peroxide customers use sodium hydroxide, also called caustic soda, for instance. For the following demonstration, we will use a small quantity of caustic soda at a 50% concentration with hydrogen peroxide also at 50%. The resulting heat-generating reaction and increase in pressure can have catastrophic consequences if they occur within an unventilated storage tank. Important: you should never attempt this experiment on your own, as the reaction can be extremely violent. Hydrogen peroxide is a non-flammable substance. It won't ignite even if in contact with an open flame. However, by releasing oxygen and heat, peroxide can promote the combustion of other inflammable substances and materials. Commonly known inflammable materials such as dry grass, wood or paper present a fire hazard if brought into contact with peroxide. Always keep this in mind. Areas used for storing or processing peroxide must be free of any inflammable materials. Also, fires that involve peroxide must only be put out with water. Hydrogen peroxide drums or containers should not be kept in areas that have a wooden floor. Pallets used for carrying peroxide drums should be made from a safe material for this purpose, like plastic. An explosive reaction can occur if organic chemicals come into contact with hydrogen peroxide in a concentrated form. For this reason, it is absolutely necessary to prevent any organic materials from coming into contact with hydrogen peroxide. To illustrate this, let us pour just a little hydrogen peroxide on this leather glove. The organic compounds contained in the leather can lead to a rapid decomposition of the hydrogen peroxide, which in turn leads to a rapid release of large quantities of heat and oxygen. The consequence? The glove catches fire. Even if leather provides adequate protection against other chemicals, contact with hydrogen peroxide will cause it to ignite and burn. Cotton, wool and viscose too can ignite upon contact with peroxide solutions in industrial concentrations. That is why you must wear appropriate protective gear over your normal clothes when in the proximity of hydrogen peroxide. Never use rags, cloths or mops to clean up if hydrogen peroxide is spilled. As we have just seen, under certain conditions, hydrogen peroxide can be a highly reactive chemical oxidizing agent. Taking appropriate safety precautions is therefore an absolute must. Wearing adequate personal protection, for instance, is indispensable to prevent any physical contact with peroxide. Depending on the potential risk of injury, protection means a full-body, lightweight chemical protective suit made of vinyl, neoprene, or Gore-Tex. Gloves with vinyl, butyl, or neoprene cuffs. Tight-fitting spray-proof protective goggles combined with a face guard. And neoprene or rubber boots. Always remember to always pull your pant legs over your boots to prevent any liquid from entering. Under normal conditions, hydrogen peroxide does not release any vapors. Under unfavorable conditions, in an enclosed space, however, measurable quantities of hydrogen peroxide aerosols or vapors can be present in the air. Inhaling these vapors can irritate or even damage airways, even at minute concentration levels. If you have been exposed to hydrogen peroxide vapors, quickly proceed to a well-ventilated area or out into the open. If you have trouble breathing, immediately consult a physician. If there is a risk of being exposed to hydrogen peroxide aerosols or vapors, use a self-contained breathing apparatus, SCBA. The areas used for storing and/or processing hydrogen peroxide should be equipped with an emergency shower and eye wash station in good working order. Before you get to work near a hydrogen peroxide storage area or dosing facility, you must first determine where the closest emergency shower is located and verify that it functions properly. If the emergency shower is connected to an alarm, speak to your supervisor before testing the system. Should there be no shower in the immediate vicinity, Make sure to bring along an adequate supply of clean water as a safety precaution. Evonik recommends that any production sites processing hydrogen peroxide place easily visible safety guidelines and operating instructions in all areas. In concentrations of 5% and above, hydrogen peroxide is corrosive to the eyes and may cause irreparable damage. For this reason, suitable eye protection is a must when handling peroxide. Normal protective goggles with side flaps do not provide complete protection. Only snug-fitting chemical protective goggles, combined with a face guard, offer the necessary eye protection. Should hydrogen peroxide get into your eyes, rinse the area abundantly with water or an eye rinse for at least 15 minutes. You should then immediately have your eyes examined by a specialist. Do not use saline solution for rinsing your eyes, as it may contain organic compounds that could exacerbate the irritation caused by hydrogen peroxide. In some cases, there may be a delayed reaction after hydrogen peroxide gets into your eyes. You should therefore immediately see a physician even if you initially do not feel any discomfort or other symptoms. If skin comes into contact with hydrogen peroxide, it can turn pale, and this is often accompanied by a slight stinging sensation. This effect is usually very brief and should cease once the skin is thoroughly rinsed. Extended contact with peroxide, however, can cause more serious damage. It can lead to severe skin irritation and blisters. In higher concentrations, hydrogen peroxide will have a corrosive effect on skin and result in an acid burn. If there is a chance you may come into contact with hydrogen peroxide, be sure to don a protective vinyl, neoprene or Gore-Tex suit, along with protective rubber gloves, eyewear, face guard and boots. If you have come into contact with hydrogen peroxide, immediately proceed to the closest emergency shower and take off any contaminated clothing while standing under running water. Should any hydrogen peroxide have reached your face, keep your protective goggles on until there's enough water on hand to ensure your eyes can be abundantly rinsed. Seek out a physician without delay. To prevent repeated contact, thoroughly rinse all tools, protective suits, gloves, boots, and other objects which may have come into contact with hydrogen peroxide. Hydrogen peroxide is a slightly acid chemical, which if it comes into contact with unsuitable or incompatible substances and materials, can cause corrosion damage on storage or processing equipment. Unsuitable or incompatible substances and materials can in turn negatively impact the chemical stability of hydrogen peroxide. For demonstration purposes, we placed metal samples of commonly used materials into beakers containing a 50% solution of hydrogen peroxide. As you can see, the copper and normal steel samples decompose the peroxide in a relatively short time, but not the samples of stainless steel and aluminium. For this reason, we recommend that any equipment used for storing and dosing peroxide be made from an aluminium alloy or high-grade stainless steel. Polyethylene is also an option for containers for hydrogen peroxide concentrations of up to 60%. Any equipment for handling and/or storing peroxide may only be used for this purpose and must be treated prior to operation. This pre-treatment process consists of a degreasing and acid cleaning stage followed by passivation. Passivation means creating a protective coating after treating the surface with nitric acid. This will prevent further contamination of the product through metal ions, such as surface rust or other fabrication materials. For additional recommendations regarding joints, seals, thread seals and other pipe parts and components, please contact your experts at Evonik. As demonstrated in our example with the balloon, Excess pressure in a closed system can have catastrophic consequences. The entire system must be adequately ventilated to prevent pressure from building up as a result of decomposing hydrogen peroxide inside closed systems and pipelines. Ball valves used in peroxide conduits should feature a small, precisely aligned hole in the ball to prevent any peroxide from being enclosed inside the valve. Any pipes between manual, automatic or check valves must be set up in a way that the system can be vented to prevent any pressure buildup when the circuit is closed. This can be achieved by installing pressure relief valves. Impurities in hydrogen peroxide are the most common cause for accelerated decomposition. To prevent the wrong chemical from penetrating into a storage tank intended for hydrogen peroxide, all flexible connections must be clearly labeled and mechanically secured. Using specific hose coupling systems for discharging hydrogen peroxide can help prevent errors. Here are a few additional recommendations for ensuring safe and proper storage of hydrogen peroxide. Use a protective filter for the vent opening. This will prevent any contamination of the hydrogen peroxide due to impurities in the air. Be sure to equip large storage tanks with adequately sized, easily opened manholes to equalize pressure in case of rapid decomposition of the stored peroxide. Storage systems should be designed with a suitable collection system in case of spillage. For example, a concrete collection basin or other safety tanks as per local regulatory standards. In case any peroxide gets spilled, be sure it can't come into contact with any incompatible chemicals. Dilute any spilled peroxide with at least 10 times as much water. Then dispose of it as per safety directions at your premises and local environmental regulations. To prevent hydrogen peroxide in industrial concentrations from mixing with other chemicals inside the wastewater system, divert large amounts of water into the water channel to dilute any peroxide residue. Never return contaminated or unused hydrogen peroxide into the storage tank or drum. The Evonik Emergency Service can be reached day and night in case of chemical contamination or spillage. The tank railcars Evonik uses to transport hydrogen peroxide are designed to meet transportation regulations and are exclusively destined for the transportation of hydrogen peroxide. All hydrogen peroxide tank railcars are discharged via connection on the roof and should only be pumped empty using a self-suction pump designed only for use with hydrogen peroxide. Using a different discharge method, for example with pressurized air or other gases, presents a greater hazard and is not recommended. Most hydrogen peroxide users have developed their own processes for identifying, sampling and discharging tank railcars, usually because only specially trained personnel is involved at this stage. Evonik engineers and technicians can support our peroxide customers in designing the appropriate discharge system for tank railcars. Tank cars containing hydrogen peroxide do not have a bottom opening and are emptied through an immersion pipe that extends from the roof to the floor. At the end of the tube's outlet connection, there is a valve labeled outlet valve. A 90-degree elbow is bolted to the valve, which is equipped with a Stores B coupling. The coupling features a protective lid to prevent any foreign matter from entering the tank. During discharge with a pump, air must be fed into the tank car to prevent a vacuum by partially opening the manhole cover. In some circumstances, the airflow created by the tank car's own vent may not be sufficient to compensate for the pump throughput during discharge. This could cause damage to the car or to the discharge pump. Evonik proposes a comprehensive range of services to ensure the safety of those handling and/or processing hydrogen peroxide. Evonik can also supply suitable tanks and accessories for a large tank facility at the customer's plant. Our engineers and technicians will accompany the installation process throughout each construction phase and the production startup. Peroxide customers can also count on Evonik for technical support for end-user applications, the latest information on the use of peroxide equipment in various industries, problem-solving support, equipment prepping and passivation, safety inspections, safety training for personnel, dilution water analysis, and assistance on-site with plant visits. Let's summarize what we've learned. Hydrogen peroxide in industrial concentrations can be handled and processed safely, as long as you keep in mind the special properties of this chemical substance. In addition, the following safety rules and recommendations apply. Hydrogen peroxide must be transported and stored in containers that have been designed exclusively for that purpose. Wear appropriate protective gear to protect your eyes and skin from peroxide. Avoid inhaling peroxide vapors. Make sure that working areas are well ventilated. Never bring hydrogen peroxide into contact with inflammable materials and substances. Store peroxide containers only on pallets made from appropriate materials, for example plastic. Do not store containers or drums on wooden floors. Keep containers and lines clean and well ventilated to prevent peroxide decomposition and pressure buildup. Areas used for storing and discharging peroxide should have an independent wastewater system to prevent contamination with other chemicals. There should always be a water outlet in the immediate vicinity. Peroxide storage and handling systems should only be set up in safe areas. Access to these areas should be reserved for trained and authorized personnel. And make sure that all areas in which hydrogen peroxide is handled have access to emergency showers and eye wash stations in good working order. Self-contained breathing apparatuses, SCBAs, should be on hand as well, in case of a peroxide aerosol or vapor buildup. Your safety comes first, so do not hesitate to see your experts at Evonik if you have any questions as to handling hydrogen peroxide, or if you would like additional information.
Evonik. Power to create.